All right, hello everyone. My recording had just died on me, so that's why I'm already written here. So I'm just going to re-talk through this. So we talked yesterday or last class about our different types of angles that refer to our parallel lines and transversals. So our first type of angle is our corresponding angles. Our corresponding angles are always congruent. So an example of corresponding in my picture over here would be 2 and 6. They are both on the same side of the transversal, and one's exterior and one is interior. They are congruent. So if I tell you that angle 2 is 70, that means angle 6 is also 70. Next up, we have our alternate interior angles. If my alternate interior angles are congruent, an example of this would be 4 and 5. They're both interior. Alternate means they're on opposite sides of the transversal. This is my transversal. So if I tell you that angle 4 is 80, then angle 5 is also 80 because they are congruent. Consecutive interior angles are the only ones that are not congruent. Okay, they are supplementary. That means they add to 180. Remember that the consecutive interior angles are on the same side of the transversal and they're both interior. So 3 and 5 are my example here. If I tell you that angle 3 is 110, then that means angle 5 is also 70 because I would just do 180 minus 110 to get 70. They should add together to be 180, which they do. Alternate exterior angles are on opposite sides of the transversal and they're exterior. Those are also congruent. So if I tell you angle 1 is 120, that means angle 8 is also 120. Moving on to the back here, we also have the perpendicular transversal theorem, which tells us that if a line is perpendicular to one of two parallel lines, so this line is perpendicular to both of these parallel lines. Perpendicular means that they form a 90-degree angle when they cross each other. If it's perpendicular to one of them, then it's perpendicular to the other. Okay. Now, this wants us to, using the relationships we just learned, identify what the angle measures are. So if angle 2 is 72, I can actually find all of these angles. Okay. First off, I can just look here at these. I have vertical angles here and supplementary angles. So not even thinking about this new stuff, just thinking about the stuff we learned last unit. If angle 2 is 72, then angle 3 is 72. And then 1 and 2 and 3 and 4 are supplementary. They're a linear pair. They're on a straight line together. So they should add to 180. So I'm going to do 180 minus 72 to get 108. That means this is 108 and then this is 108. Now, in order for me to cross away from there, so these are equal, those are equal. In order for me to get away from this little box, I get over here. Now I have to start thinking about the new angles. So this is my transversal, and these are my parallel lines. So I can say that angle 2 and angle 7, those are alternate exterior. So I can call this 72 as well because alternate exterior angles are congruent. Now you could have also used 1 and 8. You could have said 3 and 5 were consecutive interior, and you could have found you could have done 180 minus 72 to get angle 5, which would be 108. There's a lot of different ways you could get one of these bottom angles. Once you get one, you can find these 4 again easily using your linear pair relationship and your vertical angle. So these are vertical angles, 108, 108, 72, 72. Okay, so now I would just fill in my information over here. I labeled angle 3 as 72. I labeled angle 8 as 108, so on and so forth. And I found all the angles. It doesn't actually ask you for all of them. Down here, the picture gets a little more complicated because they're giving us 2 sets of parallel lines, which means that can be a transversal, that can be a transversal, that could be a transversal, C, and so could D. So every line in this picture is not only forming with another line to be a parallel set, but it's also a transversal. So there's a lot of angle relationships here. Okay. So they give us the information, the sole only information that angle 3 is 43 degrees. So once again, I can find everything within this little square. So if this is 43, then this is also 43, okay? And then I should know that 3 and 4 are a linear pair. They're on a straight line together. So I can do 180 minus 43 to get 137. That should be this angle here, okay? So now if I know 4 is 137, then 6 should also be 137. So I'm going to go ahead and label those. So angle 4 is 137. And make sure you have a little degrees there, okay? It is an angle. Angle 6 is 137, and angle 5 is 43. Now I need to move around here and start to find some other things. So I'm just going to stick with what's simple. I'm going to look just at this transversal that I'm already on, okay? Angle 4 and angle 14, those are alternate exterior. They're on the outsides of the parallel line, so they're exterior, and they're on opposite sides of the transversal. They are congruent, so this should also be 137. So angle 14 is 137. 14 and 12 are vertical angles, so they should be equal. So I know that 12 is also 137. And then I know that 12 and 13 is a linear pair. I also know 12 and 11 are a linear pair. So I can go ahead and know that these must be 43 in order to add to 180. Now I'm moving on to, I got to look at this a different way. I'm actually going to turn it, just it's more appealing to me to look at a transversal up and down. So once again, I'm going to look at my alternate exterior. That's just always the easiest one for me to see. You may find is a different one that's easier for you to see. These are alternate exterior. So that means they should be equal. So 4 and 8 should be equal. So I'm going to label angle 8 as 137. That means that angle 2 would also have to be 137 because it's vertical angles. 1 and 2 or 1 and 8 should be a linear pair. They're on a straight line together, so they should add to 180. So that means angle 1 and angle 7 have to be 43 degrees. The last step here, I'm actually going to use a different relationship just to switch it up. If you look here, angle 7 and 8 are actually alternate interior. So they're on opposite sides of the transversal, but they're interior. So those are also equal. So if that's 43, then this is also 43. So angle 9 is 43 degrees, which means that angle 15 must also be 43 because they're vertical angles, which means 10 and 16 have to be 137. So they add to 180 with those. Okay. Moving on to a little tougher, we have some problems where we actually have to use algebra in order to solve. So angle 1 is 3x plus 40. Angle 3 is 2x plus 70. Now what relationship do they share? Those are corresponding angles, okay? You don't really only need to look at this transversal. Okay, it is one transversal being, this is the transversal, it's cut by two parallel lines. One is exterior, one is interior, and they're on the same side. So that is corresponding angles. Those are congruent. So I'm just going to go ahead and set those equal to each other in order to solve. I'm going to subtract 2x from both sides and subtract 40. And I get x equals, did I mess a sign up here? Oh, this is a 70. I thought it was a 20. So sorry. Okay, so that should be minus 40, and that would give me 30. So the error, I just wrote a 2 here instead of a 7. So 70 minus 40 should give me 30. All right, moving on to another algebraic example, number 4 over here. These two problems are a little tougher. You really have to analyze what's going on. So does 4x and 56 have a direct relationship that I can see in this picture? No. And 4x and 3y minus 11, they do have a relationship. If I if I cover this middle line, you can see the relationship a little easier. These are actually alternate exterior. So I can prepare and set those equal to each other. But the problem right here is I have two variables. I cannot solve this with two variables. I need to use this 4x and 56 somehow to solve for x first. So what I can do, I could also use the 56 and the 3y minus 11, however you want to play it. So sometimes there's multiple ways to solve an equation. What I can do though is, because this is just a number, there's no variables, I can find this angle right here where I'm putting a question mark, because I know that they should be a linear pair. They should add to 180, okay? I could also find this one. They should also add to 180 together. So if I do 180 minus 56, I get that those angles should be 124. If I label this as 124 and this is 124, I can look at this one of two ways. These are vertical angles, so they're equal. These are corresponding, so they're equal. Either way, I know that 4x is equivalent to 124. And then I can divide by 4 on both sides, and x is 31. Now I already set this up over here knowing that those are alternate exterior. So now I can solve it because I can plug 31 in for x. Then I'm going to do 4 times 31, which gives me 124. And then I'm going to add 11 to both sides. I get 135 equals 3y. And when I divide by 3, I get that y is 45. Sorry, cutting off a little bit there. My last problem over here is pretty similar to this one. Right off the bat, though, I am going to think about some relationships I see. 5 and 7 are congruent, and I can see that because I have the transversal. I have my two parallel lines. One's exterior, one's interior. So those are corresponding angles. So angle 5 has an x variable, and angle 7 does too. So I can go ahead and set those equal to each other. I always like to label my picture. There's not a whole lot of room to do that here, but that's where I'd label them. So I can do 2x minus 10 and set it equal to x plus 15. And I'm going to subtract x from both sides. I get x minus 10 equals 15. I'll add 10 to both sides, and I get that x is 25. My last step is to think about the relationship between 5 and 6. If I could try to think of a relationship between 7 and 6, but there really isn't one because they're not on the same transversal. 5 and 6 are on transversal P. 7 is on transversal Q. So we can't really compare 7 and 6. They're not on the same transversal. However, 5 and 6, they're on this transversal here, and they're being cut by two parallel lines, and they're actually on the outside and alternate sides. So they are alternate exterior. So I can set angles 6 and 5 equal to each other. So angle 6 is 4 times y minus 25. So I'm going to do 2x minus 10 equals 4 times y minus 25. There's two things I've got to do here. I've got to plug in my x because right now I have two variables. So I'm going to plug in that 25 for x. And then I'm also going to distribute this 4 so that I have just an expression over here. So 4 times y gives me 4y. And this gives me negative 100 when I do 4 times negative 25. This gives me 50. So I got 40 equals 4y minus 100. I'm going to add 100 to both sides. I get 140 equals 4y. And when I divide, I get y is 35. Okay, we will go over this in class. So if you guys are struggling with this, please reach out. All right, have a great day.